Welcome to Chemistry Simplified. Our topic for today is self-ionization of water, which is also known as autoionization of water. So water is very strange in that water can behave either as an acid or a base. So if water is reacting with an acid like HCl, water would act as a base. On the other hand, water would act as an acid when it's reacting with a base such as ammonia. Because of these characteristics, water is said to be amphoteric. Let's look at a reaction where water undergoes self-ionization. So we have water reacting with itself. So one water molecule would act as the acid, as we have seen in Bronsted-Lowry's acid definition. The acid would donate a proton. So acid is a proton donor, and the other water molecule would accept the proton, and it would behave as a base because it accepts the proton. And this reaction will move forward slightly as the small arrow indicates to produce hydroxide ion, which is the conjugate base, plus hydronium ion, which is the conjugate acid. Now, since the reverse reaction is favored, so this reaction can go backward, meaning that most of the time this reaction would favor the reactant, not the product. So experimentally, they have found that at 25 degrees Celsius, the concentration of hydronium ion equals to that of hydroxide ion, meaning that both of them are 1.0 times 10 to the negative 7 molar. So the concentration of H3O and the concentration of OH minus at 25 degrees Celsius are the same. Given that, we have Kw, which is the ion product constant of water. Kw is equal to the concentration of hydronium ion times the concentration of hydroxide ion. So if we were to use the values that we were given earlier, right? Hydronium ion is 1.0 times 10 to the negative 7, and hydroxide ion is 1.0 times 10 to the negative 7 as well. So when we multiply these two together, we get Kw is equal to 1.0 times 10 to the negative 14. So that's the value for Kw. Now let's look at the relationship between hydronium ion and hydroxide ion. So if hydronium ion is greater than hydroxide ion, the solution is said to be acidic. On the other hand, if hydronium ion is less than hydroxide ion, the solution is said to be basic or alkaline. And if they are equal to each other, the solution is said to be neutral. So hydrogen ion is the same thing as hydronium ion. Okay, so it's just hydrogen ion surrounded by water produce hydronium ion. My professor a long time ago used to say that hydronium ion is nothing but a glorified proton, a glorified hydrogen ion. Well, let's look at a couple examples. Here's the first one. A solution has an hydroxide ion concentration of 5.0 times 10 to the negative 4 molar at 25 degrees Celsius. What is the hydronium ion concentration of the solution? Is the solution acidic, basic, or neutral? So we know that Kw is equal to hydronium ion concentration times the hydroxide ion concentration. and Kw is also equal to 1.0 times 10 to the negative 14. And if we were to rearrange the equation, we would get hydronium ion concentration is equal to Kw over hydroxide ion concentration. And if we plug in the values, we would have 1.0 times 10 to the negative 14 over 5.0 times 10 to the negative 4. And we would find that hydronium ion concentration is 2.0 times 10 to the negative 11 molar. The solution is basic. Why? Because the hydronium ion concentration 2.0 times 10 to the negative 11 is less than the hydroxide ion concentration, which is 5.0 times 10 to the negative 4. Let's look at example number 2. A solution has a hydronium ion concentration of 3.0 times 10 to the negative 4 molar at 25 degrees Celsius. What is the hydroxide ion concentration of the solution? Is the solution acidic, basic, or neutral? So we know that Kw is equal to the concentration of hydronium ion times the concentration of hydroxide ion, which is equal to 1.0 times 10 to the negative 14. Rearranging the equation, we have hydroxide ion concentration is equal to Kw over hydronium ion concentration. And substituting the values, we have hydroxide ion concentration is equal to 1.0 times 10 to the negative 14 over 3.0 times 10 to the negative 4. And we would find that hydroxide ion concentration is equal to 3.3 times 10 to the negative 11 molar. And the solution is acidic. Why? Because the hydronium ion concentration, which is 3.0 times 10 to the negative 4 molar, is greater than the hydroxide ion concentration, which is 3.3 times 10 to the negative 11 molar. And this is the end of our presentation. Please let us know if you had found it to be useful in the comment section. And remember to like, subscribe, and share. Thank you.